Hello everyone. In this lesson we shall be introducing probability theory. We shall start by looking at some of the events we have in our probability theory. One, we shall start by looking at intersection of events. So I've been told that for any two events A and B, the probability that A and B occur together, so this condition is very important, which can also be written as probability of both A and B occurring, is denoted as probability of A intersection B. So when you see that, it means intersection, probability of A intersection B, and it actually means that events A and, so this word is very important, and events A and B are occurring together. Yes, that's what intersection of events means. Then for union of events, we are being told that for any two events A and B, the probability that either A or B occurs, so the condition here is either A or B occurs. In the first case it was A and B. In the second case we are seeing that it's either A or B occurs, is known as probability of A union B, and it is written as probability of A union B. So when you see that, you will know that we're talking about events, and actually that probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. So that is the formula we shall be using to find the union of events. We should put it into consideration when finding probability of unions. So we are going to look at how that formula is derived in a few moments. Yes, so assuming these probabilities can be expressed on Venn diagrams, whereby we have two sets, and the first set is probability of A, whereas the second set is probability of B. Well, we know that this region over here is the intersection, and it can be written as probability of A intersection B. Then we know that the region over here in this set only is known as probability of A only. And how do we get probability of A only? We get the entire set A, which is probability of A, and subtract the intersection, which is probability of A intersection B. Then we know that the set over here is probability of B only. And how do we get B only? We get the entire set B and remove the intersection. So this region over here is probability of B minus probability of A intersection B. Yes. So to get my union means that I'm going to add up everything. To get everything that in this set, I'm going to add up all those components. So it means that probability of A union B will be got by adding, first of all, this, which is probability of A minus probability of A intersection B plus probability of A intersection B, which is there, then plus this figure there, which is probability of B minus probability of A intersection B. So we see that this term will go with that, and we shall be left with probability of A union B being equal to probability of A plus probability of B minus probability of A intersection B. So that's how we get probability of A union B. As I've told you, this formula is very important, so we must put it into our minds. So we shall look at our numerical examples to apply what we have learned so far. They're telling us that the probability that a student passes economics is 2/3. I will summarize that information. So probability that a student passes economics is 2/3. And the probability that a student passes mathematics is 4 out of 9. Probability that a student passes mathematics is 4 out of 9. And we are being told that if the probability that he passes at least one of them, so you have to interpret that statement, at least one of them, we need to know what it means. So passing at least one of them means that you've passed either economics or mathematics. And so that probability of passing either economics or mathematics is the same as the union. So that probability is actually the same as probability of economics union mathematics, and we have been told that it's actually 4 out of 5. That has to find the probability that he passes both subjects. So you also know that passing both subjects, both in this case means the intersection. So I've been given these probabilities and it has to find the intersection, because both means that it's passing both economics and mathematics, and so that and means intersection. So we shall go ahead and calculate. So how shall we get our intersection? We shall use the information we have been given to come to what we don't know. So you know that probability of E union M, which we have been given, probability of E union M, from the formula we derived, is actually equal to probability of E plus probability of M minus probability of E intersection M. So we shall substitute. We have been given probability of E union M as 4 out of 5. We have been given probability of E as 2 out of 3. We have been given probability of M as 4 out of 9. But we are looking for the intersection, probability of E intersection M. So we shall collect like terms and end up solving for probability of intersection M. So probability of E intersection M by collecting like terms will be equal to 2/3 plus 4 out of 9 minus 4 out of 5. And when we solve, we shall end up with probability of E intersection M as 14 out of 15. So that is our answer to the first question. Next, I'm going to introduce something known as the complement of events. So we should put into consideration that when you see a prime, which is actually pronounced as a complement, it means that this a prime means that event A does not occur. And we should also not put into consideration that the total probability is always 1. So what does it mean? It means that when I get the probability of event A occurring and I add it to the probability of event A not occurring, I must end up with 1, since the total probability is always 1. Similarly, if I have an event B, if I get the probability of event B occurring plus the probability of event B not occurring, I must end up with 1, since the total probability is 1. It can also apply to the intersection. If I get the probability of A intersection B occurring and I add it to the probability of A intersection B not occurring, I must end up with 1. It could still extend to the union. If I get probability of A union B occurring plus probability of A union B not occurring, or A union B complement, I must still end up with 1. So that is what we mean by complement of events. Lastly, we are going to end by introducing the Venn diagram. We have been doing Venn diagrams right from our school days, so I believe it's not something new. Yes, these Venn diagrams can help us in understanding probabilities. So if I have two sets enclosed within that Venn diagram, I know that the region over here is the intersection, and it is A intersection B. The region over here is A only, and it can be written as A intersection B complement. This means A only. The region over here is B only, and it can be written as A complement intersection B. This means B only. Then the region outside this set, we know that this entire set is known as A union B. So it means that if I get anything outside these two ovals, it will be the complement of A union B. So the region outside here is A union B, but in brackets, then complement. Yes, so from those elements of that set, we can be able to get different probabilities. For example, if I want to get the probability of A occurring, we know that set A is this entire set. So I'll add probability of A intersection B complement plus probability of A intersection B. Then if I want to get probability of B occurring, probability of B, it will be this entire set, this set over here. So it means that I'll get probability of A complement intersection B plus probability of A intersection B. So these are very important family that can help us solve a number of questions. If I want to get probability of A occurring, it is the same as getting probability of A only plus probability of A intersection B. If I want to get probability of set B occurring, it's the same as getting probability of B only plus probability of A intersection B. We shall stop at that for today's lesson. Please check out for the next video to know what comes next after this. Thank you very much for listening. Have a blessed day.